Hello students, hope all of you are doing great. Today again in this video I have discussed some numericals based on horizontal projectile motion. So we will be emphasizing on problems where the body is thrown with some initial velocity in the horizontal direction. So let's begin. The first problem goes like this, that a bomber plane is moving horizontally with a speed of 600 meter per second, and it releases the bomb which strikes the ground after 80 seconds. Now in this question it is asked, what is the angle at which the bomb will strike the ground? So here see, along x direction there is no force, that is Ax equals to 0. So Vx is equals to the initial velocity u, which is given over here 600 meter per second. As you can see in the diagram, and the dropping time is 80 seconds. So when it drops here, its velocity is v, which has two components, one along the x direction, which is Vx, that I have written as 600 meter per second, and the y component is towards the ground, that is on the negative side of y axis, which is given by Vy. So Vx is given to us along y direction. We need to find the velocity, which is given by Vy, and Vy will be obtained by the equation Uy plus Ay into the time taken t. As we all know that there was no initial velocity along the y direction, so we can say Uy is equal to 0. Initially the plane was moving in the x direction. There was no motion in y direction. So the initial y velocity will be 0. So let's put this here in this equation. Vy is equal to 0, and Ay we know is equal to minus g. So it will be minus g into t. So Vy becomes minus gt. Here the minus sign implies that the body's motion is along negative y direction, that is, it is moving towards the ground. The bomb is the body over here. So let's substitute the values. G is given here as 10. So 10 minus 10 multiplied 80. So it gives us 800 meter per second. Now see, if you see the diagram here, V is making an angle theta with the horizontal. So tan theta will be given by Vy by Vx. So let's put the values of Vy. Vy we got 800 and Vx is 600. So that gives us 4 by 3. Therefore theta is the desired angle which is asked in the question, is equal to tan inverse of 4 by 3. So we can see that the correct option is over here, option 2. Now the second problem. In the second problem we can see that it is said a projectile is fired horizontally with a velocity of 98 meter per second from a hill 490 meter high. So here the initial velocity is 98 and the height of the hill is 490, and we need to find first of all the time taken to reach the ground. So let's see how to get the time. For this we are using the second equation of motion along y direction. So along y direction we are using the second equation of motion, which is y equals to uy into the time that we will calculate plus half ay into t square. Now again in this case also uy equals to 0. In the initial condition, no motion in the y direction. So the velocity here uy will be 0. So in place of y, I am putting the height which is given as 490 meter. So if we measure it from the top of the hill, so it is towards the negative direction of y axis. So let us put minus 490, 0 multiplied time plus, and ay over here is minus g. So half multiplied minus g to t square. So minus 490 equals to minus half. If we take here 9.8, because in this question it is not said that take g equals to 10, so taking 9.8 multiplied t square, so minus gone, t square will be 490 multiplied 2 by 9.8. If we cancel this by 49, then 49 tens are and 0.2, so that becomes 400. Sorry, it is 100 into 2 by 2, so it is 100. T square is 100, therefore t is root over 100, that is 10 seconds. You could have done it using the formula t equals to, so formula for this is t equals to root over of 2h by g. You could have used this also. This formula has come from this equation itself, so straight away you can use the formula also. So this is the first part of the question. Next is the distance of the target from the hill. So that means the range is asked. This is the target point and this is the base of the hill. So this distance is asked, which is nothing but the range. Now for range we have motion in the x direction. So number 2 is range. It is along x direction. So r will be given by speed into time. Speed will remain the same, that is 98. So let's write ux multiplied the time that we found. So let us substitute 98 multiplied by 10, that will be 980 meter. Next is the velocity with which the body strikes the ground. Now from the diagram we can see that the body has hit the ground with a velocity v, with velocity v. Now its magnitude will be obtained by the resultant of, by finding the resultant of Vx and Vy. So here number 3 is to find the velocity. Now V will be given by root over of Vx square plus Vy square. For Vx we have ux which is equal to Vx, and that is 98, and for Vy we know that it is obtained by g into t. So g multiplied t, g is 9.8 multiplied 10, so it is 98. So here 98 square plus 98 square, so that is 2 multiplied 98 square, so 98 root 2 meter per second is the required velocity. Now the third problem, where we can see that from a bomber plane a bomb is dropped, and the plane is at a height of 2000 meter from the ground, and it is moving in the horizontal direction with a speed of 200 meter per second, and this is the height. Okay, so the bomb is released from the plane, so hence the bomb's initial velocity in the horizontal direction will also be 200 meter per second. So the first part is asking about the time taken by the bomb to reach the ground. So we have already covered how to get the time, calculate the time. So let's see. For time we have, you can directly use the formula, or you can write the whole equation and then put the values to get the time. So now as we know the formula for time, so let's write it. T equals to root over 2h by g. So just substitute the values. It is at a height of 2000 meters, so 2 into 2000 by g is 10 over here, so it is 400 root 400, so that is 20 seconds. Next part is asking about the velocity with which it hits the target. So as the body, the bomb touches the ground, it will travel with some velocity like this, making some angle with the horizontal, and it will have two components, one Vy and the other is Vx. So V will be the, this is V will be the resultant of Vx and Vy components. So let's find that. So V will be given by root over of Vx square plus Vy square. Now Vx is known to us, which is 200. Vx is 200. And what about Vy? Vy we obtain by using the formula Vy equals to G into T. So 10 into 20, that is 200 again. Therefore, the velocity with which the bomb strikes the ground will be 200 square plus 200 square. So it will be root over of 2 multiplied 200 square. So that will give 200 root 2 meter per second. Now this is the second part of the question. Now for the third part, it is asked that find the distance of the target from where the bomb is dropped. That is, the bomb was dropped from this point and it hits the ground at this point. So if it is say A and this is B, so basically AB is asked. From here to here the distance is asked, which is suppose say D. So we need to find D. It is not the horizontal distance from the base. I mean a point below the bomber plane from where it dropped the bomb. It is not that distance. It is not about horizontal range, but it is the distance between the dropping point and the hitting point on the ground. So now if we take this triangle, then let's name it as A, B and C. So AC is asked. So AC square will be equal to AB square plus BC square. So AB is known to us, that is 2000 square, but the range is BC, which is not known to us. So we need to find BC. How to get BC? For BC will be equal to, which is the range, will be velocity multiplied the time. So velocity in x direction is 200. Since this motion is along x direction, we will be using the x value of u multiplied the time taken was 20 seconds. So it is 4000. So 2000 square plus 4000 square. So that is 2000 square will give us 4 into 10 to the power 6 plus 16 into 10 to the power 6. So AC will be root over of 4 multiplied 10 to the power 6 plus 16 multiplied 10 to the power 6. So if we take 10 to the power 6 common, then it gives us 4 plus 16. So 10 to the power 6 when square rooted gives us 10 to the power 3, and within the root we have 20. So that can be written as 10 to the power 3 root 4 multiplied 5. So that is 2000, because if we square root 4, 2 comes out. Root 5 is the distance of the target from where the bomb is dropped. Now coming to the fourth sum, here see they have given that a body is thrown horizontally from the top of a tower and it is striking the ground in 3 seconds. So the time is given and the angle is also given, that is the body is hitting the ground and then moving in a direction with velocity v, and that velocity v makes an angle theta which is 45 degree with the ground. Okay, so these two information is given to us and it is asked to find the height first, then the speed with which the body is projected, and then the velocity of the ball when it hits the ground. So let's find the height. So while finding height, we will definitely consider the motion of the ball along y direction. So let's write the equation from which we can get the height in the y direction, right? So motion in y direction, in order to find height, we will definitely choose the second equation of motion along y direction. So along y direction, so let's take the height of the tower to be h. I am writing minus h because from top to bottom. Okay, let's write the equation first in general form. So it will be y equals to uy multiplied the time, I am taking capital T, time of flight, that is y, plus half multiplied the acceleration in the y direction multiplied the time square. Now uy is equal to 0, it is known to us. Ay is minus g, so let's substitute, and t is given here 3 seconds. 3 seconds, yes. So t is given here 3, and y is the height covered. So let's write minus h, 0 multiplied t plus half of minus g multiplied 3 square. So here they have not asked us to take g as 10, so I am writing 9.8 in place of g. 0 minus h minus half multiplied 9.8 multiplied 9. So that is 4.9, minus minus gone, so h is 4. So this is the height of the tower. Okay, so the first part is done. This is the first part. Next is the speed with which it was projected. That means this u is asked, which is again equal to vx, because in this direction no acceleration, so initial velocity along x direction is same as that of the final velocity along x direction. So let us find ux now. Now since the angle is given to us, we know the relation between the velocity along y direction and x direction is related to this angle by tan theta equals to Vy by Vx. Vx is asked and Vy is not given to us, but we can calculate it. Vy is given by minus g into t. So g is 9.8 and t is given 3. So 9.8, I am taking only the magnitude, not the sign. Here the sign implies that the body is moving towards the negative direction of y axis. So 3 by Vx. Now theta is given to us, which is tan 45 equals to 9.8 into 3 upon Vx. Tan 45 is 1. So 9.8 into 3 upon Vx, which implies Vx is equal to 9.8 multiplied 3, that is 29.4 meter per second. So the second part is done, that is the speed with which the object was thrown from the top of the tower, the velocity with which the object was projected in the horizontal direction. Now the velocity with which the body is hitting the ground. Okay, so that you have seen in the previous sums that it will be the resultant of x component of velocity and y component of velocity. So that will be Vx square plus Vy square, and here since theta is 45, we can see that Vx is equals to Vy, since theta is 45 degree. So it will be 29.4 square plus 29.4 whole square. So that is equal to 29.4 root 2 meter per second. Now the fifth sum, which goes like this, that there are two tall buildings which are situated 200 meter apart, as we can see in the diagram, two buildings, and the distance between them is 200 meter. Now in the question it is asked that with what speed a ball is thrown from this point, and this u is the speed which is unknown to us, we have to find. Be thrown horizontally from the window 550 meter above the ground. Now the throwing point is 550 meter from the ground, and the ball drops, that is its target point is another window which is 50 meter above the ground in the other building. So we can see the other building and the target window is this, which is 50 meter from the ground. Okay, so we need to find this speed. This is unknown to us, so we have to find this. Now we know that in x direction distance, that is often we find range, which is the distance. R is equal to the initial velocity with which the body is thrown multiplied the time of flight, that is the time needed by the projectile to hit the target after being thrown. Okay, so from here we get u equals to r by t. Now here the r is given, r is 200 meter, but we don't know t. So for finding t we have the formula root over of 2h by g. I hope you all know by now that how t is coming root over 2h by g. It is coming from the second equation of motion, this equation, that is h equals to uy multiplied t plus half ay multiplied t square. Now uy is 0, so 0 into t minus half gt square. So that gives us t square equals to 2h by g, and therefore t equals to root over of 2h by g. Okay, so I have straight away used the formula t equals to root over of 2h by g. So h here is known to us. Now you see that the height will be 500, because 550 minus this distance 50 meter. Okay, so in place of h we will put 500. So root over of 2 multiplied 500 upon g is given here as 10. So it gives us root 100, that is 10 seconds. So the ball takes a time of 10 seconds to get dropped to this target window. Okay, now then let's find u. So u becomes then, r was given 200 by time is 10 seconds, so that is 20 meter per second. So the ball was thrown with an initial velocity of 20 meter per second. Now let's move on to the next sum, that is the sixth sum, which goes like this, that a ball is rolling from the top of a stairway with a horizontal velocity of u. So the initial horizontal velocity is given to us. If the steps are of height h, so height of each step is given h and the width of each step is given as b, then the ball will hit the edge of the nth step, where we need to find n. So 4 options have been given for n. So let us see which one will be the correct option for n, where n is the number of steps. Okay, so the diagram is like this. This is the stairway. Now in the stairway we can see how many steps, 1, 2, 3, 4, 5 and 6. So each stairway has a width of b and a height of h. Now the height h corresponds to the vertical distance. So if there are 6 steps in this staircase, then we can see that there will be 6 heights, which will comprise to the height of the stairway. Like this height will correspond to this to this. So if we add on the 6 heights, h plus h plus h plus h plus h plus h, that is 6h, we will get over here the same height, that is the sy. Similarly, for finding sx, we have to add up the width of each staircase. So let's count the number of b's that we have. That is again equal to 6, because in the stairway we have 6 steps. So as many steps will be there in the staircase, that many widths will be there to get the x distance. And similarly, in the y distance, that many h will be added to get the height of the staircase. That is, sy will be given by nh, and I am putting a minus because from top to bottom we are taking the distance, that is why the negative sign. And for sx it will be nb, where n is equal to number of steps. So first of all, along x direction, the displacement is taken as is sx, which is given by n into b. B is the width of each step and n is the number of steps. So n multiplied b will give the total distance in the x direction. Okay. Now this sx is nothing but the range, and the formula for horizontal range we know, r is equal to the initial velocity with which the ball was projected, that is it started rolling, and the total time needed is t to hit the edge of the last step, that is the nth step. Okay, so here therefore sx is equal to r, so we can write ut is equal to nb. Therefore t is equals to nb by u. So we got the time. Now along y direction, so since this type of motion is a 2D motion, we need to find the motion in two directions, x and y. The displacement is taken as sy, which will be equal to nh with a minus. Okay. Now for displacement along y direction, let's write the equation. That is sy is equal to uy multiplied t plus half ay into t square. Uy we know 0, ay is minus g. So in place of sy I am writing nh minus n into h equals to 0 minus half g t square. Now let us substitute t with nb by u. So minus nh is equals to minus half multiplied G multiplied NB by U square. So that gives us the minus is cancelled. NH is equals to G by 2 N square B square by U square. So from here we can cancel one N and we need the value of N, right? So we have to find N. So it will be 2H U square by GB square. So let's see which is the correct option. That is the fourth option, 2HU square by GB square. So this will be the correct option for N. Hope these numericals will help to clear the concepts of this case of projectile motion. That's all for today. Hope to see you with another set of numericals on a different case of projectile motion. Till then, stay fit and keep studying. Thank you all.